that beautiful arc. It's so smooth, it's practically a parabola.
Exactly. That curve is just like the parabola we learned about in class.
So does that mean we can use a quadratic equation to map out the flight path?
Yes, let's connect the dots between our game and some math magic.
That throw was great, but how do we actually calculate the perfect path?
And how high will it go?
Maybe we can predict exactly where it lands.
Right, the roots of the quadratic will tell us the launch and landing times. Let's investigate.
Hey everyone, earlier when we were playing with the Frisbees, we noticed something cool. The path it took through the air looked like a curve.
Turns out the path of the Frisbee can be described by a quadratic equation. Let's assume that the height we threw the Frisbee from is equal to 0. Then the equation f of t is equal to negative t squared plus 12t minus 20 maps the path of the Frisbee. Let's solve this equation in 3 fun ways to show the time that we threw the Frisbee and when it landed.
The first method is called Vieta's formula.
And Kira is going to show us how it works.
Vieta's formula tells us that in a quadratic equation is at squared plus bt plus c equals 0, and the roots r1 plus r2 equals negative b over a. R1 times r2 equals c over a. Our Frisbee equation that Ariash wrote would give us that we need to find what a, b, and c are. So a equals negative 1, b equals 12, and c equals negative 20. And so, knowing our a, b, and c, we can fill these in to go negative 12 over negative 1, which would equal 12, and then multiply our roots to get negative 20 over negative 1, which is also a positive number, 20. So we need to figure out a pair of numbers that satisfies both conditions of adding to 12 and multiplying to 20. So let's think of factors of 20. Well, some factors are 1 and 20, 2 and 10. 1 plus 20 equals 21, which would not equal 12, what we're looking for. 2 plus 10 equals 12. Let's just check 4 and 5 to make sure we're doing this right. 4 and 5 would equal 9. So 2 and 10 have to be our answers because they satisfy both conditions of adding to 12 and multiplying to 20. That means T1 in our equation up here would equal 2 and T2 would equal 10. Since we're talking about flight of Frisbee, meaning that we threw it at 2 seconds and it landed at 10 seconds. And this is our answer. Ariash, back to you.
Great job, Kira. Now I'll show you how to solve the same equation using the completing the square method. We start with our equation negative t squared plus 12t minus 20 and divide the entire equation by negative 1. And what this gives us is t squared minus 12t and plus 20 equals 0. Then we take half of b and square it. Since b is negative 12, half of b is b02 is equal to negative 6. Negative 6 squared is 36. Now we add this to our first equation. So we have t squared minus 12t plus 20 plus 36 equals 36. So what will this do? It will create a trinomial that perfectly in a square and can be factored into 2 binomials. So this part of the equation, t squared minus 12t plus 36, is a perfect square. So we can take 20 to the other side. getting t squared minus 12t plus 36 is equal to 16. So to find the roots of t squared minus 12t plus 36, we have to find two numbers that add to negative 12 and multiply the 36. What numbers could those be? So negative 6 and negative 6 both multiply to 36 and add to negative 12. So this equation can become t minus 6 into t minus 6 is equal to 16. So this is the same as t minus 6 x squared equals 16. Now to solve this, we take the square root of both sides. So we get t minus 6 is equal to plus minus 4. And now we have two equations. So if t minus 6 was equal to 4, t would equal 10. And if t minus 6 would be equal to negative 4, t would be equal to 2. So these are the roots of our quadratic, and they represent the time at which the frisbee was thrown and when it lands.
How high did it go?
Great question. We can convert our equation to vertex form to find the coordinate when the frisbee was at its highest point. So we have the equation t minus 6 squared equals 16. And to convert it to vertex form, we can move the t minus 6 squared to the other side, getting negative t minus 6 squared plus 16 equal to 0. Now our equation is in the form a into t minus h squared plus k. To find the vertex, we can use the coordinates h and k as h as the x coordinate and k as the y coordinate to find the point where the frisbee was at its highest. So from this equation, h is 6 and k is 16. So meaning at 6 seconds, the frisbee was at its highest point of 16 feet. On to you, Betty.
Now it's time for the famous quadratic formula. In this case, we have a equals negative 1, b equals 12, and c equals negative 20. And the quadratic formula is t equals negative b plus or minus b squared minus 4ac all over 2a. T equals negative 12 plus or minus the square root of 12 squared, and then minus 4 times our a and c value, which is negative 1 and negative 20. And this is all going to be over 2a, and a is negative 1, so it's going to be negative 2. And then we can start simplifying to get negative 12 plus or minus square root of 144 minus 80 all over negative 2. So then we can simplify further, and we know that 144 minus 80 is 64. And again, all over negative 2. Negative 12 plus 8 over negative 2, which is going to give us negative 4 over negative 2, or 2. And then we can also do t equals negative 12 minus 8 all over negative 2, which will give us negative 20 over negative 2, which is 10. And there you have it. The frisbee was launched at 2 seconds and landed at 10 seconds, just as Kira and Irish found. It must be correct.
So our quadratic tells us that 2 seconds and 10 seconds, the launch and landing times, the frisbee is at ground level. It also tells us that the highest point, which happens halfway at 6 seconds, is the vertex, which in this case would be 16. However, in the game, we have to consider that our hands bring the frisbee 3, feet off the ground, and therefore 3 plus 16 gets you 19 feet off the ground at the highest.
How do we decide which one to use when we need to solve a quadratic equation?
Should we always choose Vieta's formula?
If you have a quadratic that is factorable, you can use the Vieta's formula because it's the fastest and easiest way to solve it.
If the middle term is even and the equation isn't factorable, you can use the completing the square method. Plus, it's also the easiest way to find the vertex of the parabola.
And if the equation isn't factorable, or the middle term is odd, or the roots make decimals, then the quadratic formula is the way to go. Should we try to solve some problems for MathCounts? Sure, that sounds like a great idea. Who would like to give it a try?
Wow, everyone is up to the challenge. In that case, let's solve 2 MathCounts problems.
How about Nathan and David? Why don't you solve the first one?
Since the b or middle term is even, we can use the completing squares formula.
Good idea.
First, we take half of the coefficient of b, which is -8. Half of -8 is -4, and we square it. We add the square to both sides of the equation. On the quadratic side, we put it right before -209.
The first 3 terms form a perfect square trinomial. Don't forget the plus or minus sign.
Finally, solve x by adding 4 at both sides.
So the 2 possible solutions for x are
Wow! The solutions to the equations are 19 and -11.
now the problem asks for the positive difference between the factors.
Right. We need to subtract the roots. That's 19 plus 11, which equals 30. And that's our answer. Positive difference between the factors is 30. Wow.
How about Lucy and Sue to solve the next one?
Let's solve this in Vieta's formula. The A, B, and C terms are 2, -11, and 12.
And inputting them into the equation would be R1 plus R2 equals -11 over 2. And that would equal 11 over 2.
And that's our answer.
See how the roots of our quadratic represent the moments of the Frisbee touches the ground? The first root marks the launch, and the second marks the landing.
And the vertex shows the peak, the very highest point of its flight.
That's the power of math. It turns everyday play into a beautiful story of curves and numbers.
Now it's your turn to join the adventure. Let's test your skills of a couple of challenge problems.
Pause the video if you need some time, then check our answers with our on-screen solution.
Math is all about discovering connections. Today, we saw how a quadratic equation maps exactly to the flight of a Frisbee.
Whether you solve it using Vieta's completing the square or the quadratic formula, each method shows a different piece of the story.
Thanks for flying with us on this math adventure.
Keep exploring, keep playing, and keep solving!